Right now, as you sit there, something is speaking to us from 15 billion miles away. The signal left more than 22 hours ago. It crossed the space between stars at the speed of light, arrived faint enough to be measured in fractions of a fraction of a watt, and landed on a dish here on Earth. That happens every day. Nobody thinks about it. But for 5 months, that signal meant nothing at all, not static, not silence, a pattern, the same ones and zeros repeating over and over, carrying no information whatsoever. The engineers at the Jet Propulsion Laboratory compared it to a dial tone. The machine was awake. It was receiving every command they sent. It was doing what it was told. It simply could not say anything anyone could understand. It is not broken. It is not lost. It was built before the personal computer existed. At the heart of this story is a computer with 69.5 kilobytes of memory, all of it. That is less storage than one blurry thumbnail image on the phone in your hand. Project scientist Linda Spilker later said the size of that memory was the biggest challenge in the whole anomaly. This is the story of Voyager 1 and of 5 months of silence that was not silence. By the end of this, you will understand what one stuck bit says about every machine you now trust with your life. You will know why on April 17, 2026, NASA switched off another of its instruments, and you will know what 2027 means to the people still fighting for it. Stay with me, because by every ordinary standard, this should not have been fixable. Before we go back, one thing: if you were around in 1977 or you ever built something that outlived its own manual, this channel is for you. Subscribe. Stories like this one get quieter every year. Now. September 1977. Cape Canaveral, September 5, 1977. Voyager 1 lifts off on a Titan Centaur 16 days after its twin, Voyager 2, which went up on August 20th. The younger one launched second and got there first. That was the plan. And the plan was modest: a tour of the outer planets, Jupiter, Saturn. A few years of good data, a handful of photographs nobody had ever taken before, and then whatever happened after that was not really anybody's problem. 4 years. That was the mission. Nobody in that room was designing for 2026. The 3 computers aboard each Voyager were built for this mission and nothing else, custom work from General Electric. In an era when a computer was something you laid out by hand. There was no downloading more memory. There was no next version. Engineers sat at drafting tables and argued over individual words of storage. And somewhere in that process, a person had to look at a capability they wanted and cut it because there was no room. 69.5 kilobytes for everything. Think about what that means. Your phone holds more than that in a single text message thread. Those men and women were rationing storage the way you would ration water. One of those 3 computers was called the Flight Data Subsystem, the FDS. Its job is simple to describe and impossible to replace. Every instrument on the spacecraft produces readings. So do the health sensors, the ones that report temperature, voltage, whether the machine is warm enough to keep functioning. All of that is raw noise until something organizes it. The FDS gathers it, packages it into one clean stream, and hands that stream to the radio for the long walk home. That is all it does. That is everything. Nothing else on Voyager can do that job. There is no backup FDS waiting in a cupboard, no redundant unit to switch to. One computer packages every single thing Voyager 1 has ever told us. Every image of Jupiter, every measurement from beyond the heliosphere, all of it went through that one box. The FDS is not the spacecraft's brain. It is the spacecraft's voice. The people who built it expected it to be useful until about 1981. They built it well anyway, because that is how they built things. None of that was supposed to still matter half a century later, but it did. March 1979, Jupiter. The pictures come back, and they are nothing like the models. Volcanoes erupting on a moon nobody expected to be alive. Rings around a planet that was not supposed to have any. November 1980, Saturn. Voyager 1 swings close to Titan to get a look at that thick orange atmosphere, and the price of that look is the rest of the solar system. The encounter flings it up and out of the plane the planets orbit in. No Uranus, no Neptune, just up and away forever. That was supposed to be the end. The cameras had done their work. The mission was complete. It kept going through the 1980s, sending data nobody had budgeted for. Through the 1990s, when the engineers who designed it began to retire. In 1990, it turned around and took the photograph Carl Sagan asked for, the one where Earth is a single pale speck in a band of scattered sunlight. Then it turned back and carried on. August 2012. Voyager 1 crosses the heliopause, the outer edge of the bubble of particles streaming off our own sun. It becomes the first object built by human hands to leave the sun's neighborhood entirely and enter the space between stars, 35 years into a 4-year mission. And it did not stop there either. Today it is more than 15 billion miles out. This year, 2026, it crosses a threshold with a name that ought to stop you, one light day. From here on, a message takes a full 24 hours to reach it. Nothing we have ever built has been that far away, and nothing will be again for a very long time. Every year after 1981 was borrowed. Understand that plainly. This machine spent 4.5 decades exceeding a specification written by people who assumed it would be dead and forgotten before their own careers ended. It outlived their assumptions. It outlived some of them. But there is a cost to lasting this long that nobody accounted for in 1977. Solder joints age, chips age. Every component aboard has been sitting in radiation at temperatures that would crack steel for 49 years. The same endurance that made Voyager extraordinary was quietly wearing it down from the inside. Then, on the 14th of November 2023, it started talking nonsense. Many of you already know what a bit is. Sit with the explanation anyway, because the shape of this failure matters more than the vocabulary. A bit is one switch, on or off, 1 or 0. That is the whole of it. Memory is nothing more than a great grid of those switches arranged in rows, each one holding its position until something tells it to change. And a stuck bit is exactly what it sounds like. A switch that has welded itself into one position and will not move again. It reads the same value forever, no matter what you write to it. Picture a piano. Every key works. The hammers are true, the strings are in tune, the pianist knows the piece by heart. But one key is jammed down, it will not lift. Play anything that touches that note, and what comes out is wrong every single time, and there is nothing wrong with the playing. Now make it worse. The jammed key on Voyager was not holding a note, it was holding part of the sheet music. The failed region of memory did not just store readings, it stored a piece of the FDS's own software, the instructions the computer follows to do its job. Those instructions were now unreadable. The machine had lost part of its own knowledge of how to speak. It went on gathering data, went on packaging it the only way it still knew how, and what came out the other end was that repeating pattern, a dial tone. Here is the scale. Roughly 3% of the flight data subsystem's memory was affected, around 256 words of storage. Not gigabytes, not megabytes, 256 words on a computer with a little over 69,000 bytes to its name. One welded switch, smaller than a grain of rice, sitting inside a machine that had crossed the edge of the solar system. And this is the part that is genuinely cruel. Voyager was not dead. It was receiving every command from Earth. It was executing them correctly in order, exactly as instructed. It was alive out there and listening and doing its best. It just could not answer. Think about what that actually means for the people whose job it was to fix it. They expected software. That is what the history told them. Voyager had done strange things before and recovered. In May 2022, the attitude control system, the part that keeps the spacecraft pointed at Earth, started reporting readings that made no sense at all. The spacecraft itself was fine. It was pointed correctly, it was healthy, it was simply describing itself wrongly. That one turned out to be a routing problem, and it was solvable. So the team went looking for something like that again, something you could reset. They started the way you would start. Turn instruments off, one at a time, and watch whether the pattern changes. Turn them back on, isolate, eliminate, nothing changed. The dial tone kept coming. So in early March 2024, they tried something more aggressive. They sent a command telling the FDS to dump its entire memory back to Earth. The team called it a poke. Read out everything you are holding, every line of code, every variable, and send it home and let us look at it ourselves. The readout came back, and there it was. Linda Spilker put it plainly afterward. That, she said, was what led them to finding the piece of hardware that had failed, and that chunk of memory. Hardware, not software. You cannot reset hardware. You cannot patch a switch that has physically stopped moving. There is no command in any language that repairs silicon from 15 billion miles away. And here is what almost nobody mentions. They never found out why. Two explanations are on the table. A high-energy particle, one of the countless charged fragments moving through interstellar space, struck the chip and killed it. Or the chip simply wore out after 46 years of doing its job in the cold and the radiation with no one to service it. Researchers have not determined which explanation is correct. At this distance, they never will. Sit with what that meant for the engineers in that room. They had to design a repair without knowing the cause. If it was a particle strike, it was bad luck, and the rest of the memory was probably sound. If it was age, then every other chip on that computer was 46 years old too, and the next one could go next week. And here is the twist almost nobody outside the mission team is talking about. A stuck bit is not exotic. That is the thing nobody says out loud. It is not a deep space phenomenon. It is not a Voyager problem. It is the ordinary end state of solid-state memory, the way memory fails when it has been asked to work long enough. And the same physics is running in the pacemaker regulating somebody's heartbeat tonight, in the engine control unit in your car, in the infusion pump beside a hospital bed metering out a dose, in the flight computer of the aircraft passing overhead right now. This does not stay out there. It reaches back here. But there is a difference, and it does not favor us. Voyager's memory was 69.5 kilobytes, small enough that when it broke, engineers could ask the machine to hand over every last line it was holding and then read all of it by eye until they found the fault. The whole thing fit on a desk. Nothing you depend on today can do that. The software in a modern car runs to 100 million lines. Nobody has read it, nobody will. We built systems we can inspect completely, and then we abandoned that for systems too large for any human being to check. And now, the second half of it. Voyager's failure was loud, a wall of nonsense, obvious from the first hour, impossible to miss. A stuck bit in a bigger system does not announce itself that way. It produces a number that is slightly wrong, a reading off by a fraction, a dose off by a decimal. Everything continues, and the machine reports that everything is fine, and it is not lying because as far as it knows, everything is fine. We do not yet know exactly what that means. But the fact that we now need to ask the question at all is itself a shift in how we understand our own vulnerability. Start with what they could not do, because that is how the room would have worked it. The chip cannot be replaced. Nobody is going there. There is no service call, no spare in a drawer, no astronaut, and there never will be. That chip is dead, and it stays dead for as long as the spacecraft exists. So the code has to move. Whatever instructions were sitting in that ruined patch of memory have to live somewhere else. Fine. Find an empty space and put them there, except there isn't one. 69.5 kilobytes, and after 46 years of software patches and workarounds, not one free block anywhere in that computer was large enough to hold the section in one piece. Spilker said it directly. The size of the memory was the biggest challenge in the anomaly. That is the box closing. The code cannot stay, the code cannot fit. So they did the only thing left. They took the affected software apart, break it into sections, find the small gaps scattered across the memory, the leftover corners, and place a fragment in each one. Then rewrite every cross-reference inside that code, every pointer, every jump address, so that the pieces still find each other and still execute as one working program. Reassemble a machine's instructions in a shape their original authors never intended. Some of you know exactly what that is. That is hand-patching assembly on a custom computer designed in the early 1970s with no debugger, no simulator you fully trust, no rollback, and no second attempt. And then there is the last constraint, the one that turns engineering into endurance, 22.5 hours each way. Every command was a question with a 45-hour answer. You send it, you go home, you come back the next day, and it has not arrived yet. And if you got it wrong, if a single address was off, the spacecraft might stop responding entirely and you would find out about it a day and a half after it happened. They chose carefully what to move first, not the science. The engineering data, the health and status telemetry, because until they could read the spacecraft's own vital signs, they were working blind on everything else. April 18, 2024. The command goes out from the Deep Space Network, then nothing. Almost a full day for the signal to cross 15 billion miles. Then whatever happened out there happened with nobody watching, then another 22 and a half hours for the answer to come home. April 20th, 2024. The data arrives and it is readable. Health, status, temperature, voltage. For the first time in 5 months, they could see how their spacecraft was doing. Stop and sit with that for a second. The engineering data was only the first piece. Over the following weeks, they went back and did it again and again. Each remaining section of affected code taken apart, scattered into whatever gaps were left, cross-references rewritten, sent out on that 45-hour round trip, one at a time. By June 2024, the science instruments were reporting again. Understand what actually happened there. They did not restart a computer. They did not restore from a backup. They rebuilt the internal architecture of a machine's software while it was flying through interstellar space, working from documentation written on paper by people who in many cases were dead, in a language and a layout that predates the internet by 20 years. And it held. Then October 2024, Voyager throws a fault. Its protection system decides something is wrong with the power draw and does what it was designed to do back in the 1970s. It shuts down the main X-band radio transmitter and falls back to the spare. That spare is an S-band transmitter. It had not been used since 1981. 43 years, sitting cold and unpowered in the dark, at temperatures near absolute zero, absorbing radiation the whole time. Nobody had tested it. Nobody could have. It switched on. It worked. The engineers found the signal faint and on a frequency nobody had listened for in 4 decades, and Voyager was talking again. Almost nobody outside the mission team talks about that. Think about the phone you replaced because the battery died in 3 years. Think about the appliance that failed the month after the warranty ended. Then think about a radio built by hand in the 1970s, switched off during the Reagan administration, that came on when it was finally asked. They did not build it to last 43 years in storage. They built it properly because that was the standard, and 43 years happened to be what properly turned out to mean. And here is the frame that ought to sit with you. Whatever happens next, that machine is not stopping. It will keep moving out through the galaxy at 38,000 miles an hour, long after the last engineer who touched it is gone, long after everyone watching this is gone. But none of that prepared anyone for what came next. They gave it back its voice. They could not give it back its strength. Voyager runs on a radioisotope thermoelectric generator. Plutonium decays, that decay produces heat, and the heat is converted into electricity. It is elegant and it is completely inflexible. The plutonium decays on its own schedule, and no command from Earth changes that. Every year, about 4 watts less. A nightlight draws more than the margin they are working with now. February 27, 2026. A routine roll maneuver, the kind the spacecraft has performed hundreds of times. The power drops further than anyone expected, close enough to trip the undervoltage protection, the system that would shut the spacecraft down into safe mode. So on April 17, 2026, JPL sent the command. Off went the low-energy charged particles experiment. It had been running almost without interruption since 1977, 49 years. It measured the particles moving through the space between stars, and it did that job from the day it left Florida until this spring. 7 of the 10 instrument sets are now dark. 2 remain on Voyager 1. One listens to plasma waves, one measures magnetic fields. Kareem Badarudin, the mission manager, said what everyone there was thinking. Shutting down a science instrument is not anybody's preference. It is the best option available. And there is no replacement. There is no second interstellar probe funded, none planned, nothing on any drawing board that will be out there in our lifetime. When Voyager stops answering the questions it was asking, stop with it, for a generation at least. But they are still trying. There is a plan the team calls the Big Bang. Swap out a group of power-hungry components all at once, replace them with lower draw alternatives, and free up enough electricity to keep the spacecraft warm enough to keep working. Possibly warm enough to bring an instrument back. They will test it on Voyager 2 first. More margin, closer to home, safer to lose. Those tests were scheduled for May and June of this year. The team is cautious. They are not making promises, but they are still trying. Now come back to that stuck bit, because there is one more thing that deserves to sit at the center of this story. The people who wrote that code were writing for 4 years. They did not know their work would be taken apart in 2026 by engineers who were not born yet, who would never meet them, who would have nothing but their paper documentation and their choices to go on. And yet, when that generation came looking, the work held up. It was clear enough to read. It was structured well enough to cut apart and put back together in flight. That is the legacy. Not the spacecraft, the margin. They left room. Nobody asked them to. Nobody was going to check. Some of you did the same thing in a shop or a plant or a substation somewhere, on a job where the specification said one thing and you quietly did better because that was how you were taught. Nobody thanked you for it. Somewhere out there, it is still running and your name is not on it. Here is the harder part. Voyager 1 will not be switched off. Nobody's going to pull a plug. It will just get colder and quieter, and one day the signal will not arrive at the appointed time. The team will wait. They will wait longer than they need to, and eventually they will stop waiting. The spacecraft will keep going anyway. Out past everything at 38,000 miles an hour, silent for millions of years. You already know what this is really about. Lasting longer than anyone expected is not the same as lasting forever. The dignity was never in avoiding the end. It was in what got done with the years nobody counted on. So here is what I want you to take away from this. The impossible part was never the physics. The physics was hard, but it was solvable. The impossible part is that a design finished in the 1970s left enough room for strangers half a century later to reach in and save it. 69.5 kilobytes laid out by hand, still returning data from between the stars. Meanwhile, we build things that go obsolete before the warranty runs out. We are the species that keeps talking to something that cannot answer quickly because it might. September 2027 is the 50th anniversary. The team is trying to get there. The power drops 4 watts a year, whether anyone is watching or not. One stuck bit, 256 words of memory, 45 hours to ask a single question. So what have you built that is still running somewhere that nobody knows your name for? If this is the kind of story you want more of, subscribe and turn on notifications, because these get harder to find every year. And tell me in the comments, where were you in 1977? Or tell me about the machine you kept alive, past the day it was supposed to die, the one you were still fixing long after the manual said not to bother. Send this to someone who built hardware that outlived its own paperwork. They will understand it faster than anyone.